Gyronics.
Welcome to this algebra tutorial. In this series, we'll begin by mastering the basics like simplifying algebraic expressions, factoring, and solving quadratic equations. Then we'll take things a step further with linear algebra, exploring different methods to solve systems of linear equations, including substitution, elimination, and using matrices. By the end of this series, you'll have a solid foundation in algebra and be well equipped to tackle more advanced mathematical challenges. So let's get started. And this will be our topic outline. First, we'll define what is an algebraic expressions, the properties of real numbers, and the rules in simplifying algebraic expressions. So we have the rules for exponent and we also have the rules for radical. So first is the algebraic expressions. So this is simply an expression made up of letters and or numbers with signs. So this is an example of an algebraic expression. So we have 2x plus 3y minus 1. If for example we add, let's say, equals 15, this is not an expression anymore. This is called an algebraic equation. So from the root word equal. So we have equal sign, that's equation. But without that equal sign, let's say we have 2x plus 3y minus 1, this is only called an expression. And the letters in this algebraic expressions is called a variable. So these are the number with varying values. So from the root word vary, which means this variable x and y, you can assign any value. So you can assign x equals 2, x equals negative 3. The same with y, you can assign y equals 10, y equals negative 20. Okay, so it varies its value as opposed to what we call the constant. So constant is a fixed number. In this case, we have this negative 1. So this negative 1 doesn't change its value. So another part of this algebraic expression is the numerical coefficient or simply coefficient. So this is a constant number or a fixed value, but this is beside the variable. So it tells how many times the variable is being multiplied. In our case, we have these 2 and 3. So the numerical coefficient of x is 2. So which means whatever value you assign to x, you multiply them twice. And the coefficient of y is 3. So whatever value you assign to y, you multiply it 3 times. We also have what we call a term. So this is a combination of variable and constant which is separated by addition or subtraction. So for this given algebraic expression, we have 3 terms. We have 2x, 3y, and 1. So 2x and 3y is separated by addition, right? And 3y and 1 is separated by subtraction. So this algebraic expression have 3 terms. So the 2x, the first term, 3y, the second term, and the last term is 1. Next are the properties of real numbers. So first we have commutative law of addition. So a plus b is the same as b plus a. So for example, we have 2 plus 3. That is also the same with 3 plus 2. So 2 plus 3 is 5 on the left side. 3 plus 2 on the right side is also 5. So we also have commutative law of multiplication. So a times b is the same as b times a. So of course, 2 times 3 is the same as 3 times 2. So 2 times 3 is 6 on the left side of the equation. 3 times 2 on the right side is also 6. Next is the associative law of addition. So this one, the order doesn't matter. For example, you can add first b plus c, then a. That is the same as if we add first a plus b, then c. So for example, we have this equation. 1 plus the sum of 2 plus 3 is the same as if we add first 1 plus 2, then 3. Okay, so this is 1 plus 5, right, in the left side. So this is also equivalent if we add first 1 plus 2, which is 3 plus 3. Okay, so we have 6 equals 6. So next is the associative law of multiplication. So the same, the order of multiplication doesn't matter. So a times the product of b times c is the same as if we multiply first a times b, then c. So for example, we have this equation. 2 times the product of 3 times 4 is the same if we multiply first the 2 times 3, then 4. So this is 2 times, of course, 3 times 4 is 12. That is the same if we multiply first 2 times 3, which is 6 times 4. So this will give us, of course, 24. Next is the distributive law of multiplication. By the way, we don't have distributive law for addition, only multiplication. So a times the sum of b plus c is equivalent to a times b plus a times c. So we kind of distribute this one, a times b plus a times c. Okay, so this one, a times b plus a times c. Okay, so remember this pattern. So for example, we have this one, 2 times the sum of 3 plus 2. So we can distribute this 2. This is 2 times 3, right? So this one, 2 times 3 plus 2 times 2. Okay. So this is the left side. If you have 3 plus 2, that is 5. So we have 2 times 5. That is the same if we distribute the multiplication over addition. So this is 2 times 3, 6. Plus 2 times 2, which is 4. And this will give us 10. So take note of this process. Okay, next, let's proceed to simplifying algebraic expressions. And we have rules. First, let's tackle the exponent rules. Okay, so for product, we have rules. Let's say you have two expressions with the same base, x. Take note, it's not different value, but the same value of base. So in multiplying these two expressions with the same base, we add the exponent. So example, we have these algebraic expressions, 2 raised to 2 times 2 raised to 3. So take note, the same base. The base is 2, but different exponent, 2 and 3. So we can copy the base, 2, but we add the exponent. So 2 plus 3. So to prove that this is true, we have first this one, 2 squared. So which means we multiply 2 times, right? 2 squared is the same as 2 times 2. How about 2 raised to 3? So it means we multiply 2 3 times, right? So 2 cubed is 2 times 2 times 2. So this is the left side of the equation. This is equal to 2 raised to 5 since we add the exponent 2 plus 3. So how many 2 we have in the left side? We have 1, 2, 3, 4, 5. So which means we multiply 2 5 times. So that is the same as 2 raised to 5, right? So that's your proof that this product rule is true. So we also have quotient rule. This is during division. The same base but different exponent. So this time, instead of adding, we subtract. Okay, so take note of this. In multiplying the same base, we add exponent. In dividing the same base, we subtract. So example, we have this one, 2 raised to 4 divided by 2 raised to 2. This is the same as, so we subtract. Take note, the first number must be the numerator or the exponent of the numerator. So numerator, exponent of numerator minus the exponent of denominator. So to prove that this is true, 2 raised to 4, which means you multiply 2, how many times? 4 times. Okay, so 1, 2, 3, 4. 2 squared, so 1, 2. So this is equivalent to, of course, we subtract 4 minus 2, that is 2 raised to 2. So we have 2 here at the numerator and other 2 in the denominator. So this cancels out. 2 divided by 2 is 1. So another 1 can cancel this out. So what's left is 2 times 2, which is equivalent to 2 squared. Right? Okay, so this is the quotient rule. Okay, next, the power rule. So if we have, for example, an expression raised to an exponent n, and we raise it to another exponent m, so in raising power to power, multiply the exponent. So for example, we have this one, 2 squared, we raise it to another exponent, which is 3, or another power, which is 3. So this is the same as 2 raised to 2 times 3. So you multiply these exponents. Okay? So to prove that this is true, 2 squared is what? 2 times 2, right? Raised to 3. So this is the same as 2 raised to 6. Okay, so if we multiply 2 times 3, that is 6. So what does it mean, this one? Which means you multiply 2 times 2 3 times. Right? So we have Okay, 1, 2, 3. 3 times. So this is the same as 2 raised to 6. So how many 2s? We multiply 1, 2, 3, 4, 5, and 6. Okay, so that's your proof. Okay, next is the power of 0. So any number raised to 0 is equal to 1. So except if that number is 0. So other than 0, any number, let's say 5 raised to 0, 1 million raised to 0, that is always equal to 1. So to prove that, let's have this example. We have 2 raised to 3 divided by 2 raised to 3. The same numerator and denominator, this is equal to 1. Right? But by quotient rule, so we have the same base, which is 2. So when dividing the same base, we subtract the exponent, right? So 3 minus 3, of course, that will give us 2 raised to 0, which is equivalent to 1. So this is the power of 0 rule. Okay, next is the negative exponent. So if you have, let's say, a number raised to a negative exponent, you can change that number or that sign from negative to positive by, of course, getting the reciprocal of that number. X raised to negative n is equivalent to 1 over x raised to positive n. So example, we have this one, 2 raised to negative 2. So to make it positive, we simply get the reciprocal, which is 1 over 2 raised to 2. Instead of negative 2, it becomes now positive 2. So to prove this one, we can have negative 2 or we can represent this 2 raised to negative 2 as 2 raised to 0 over 2 raised to 2. By quotient rule, so the same base 2, so we can subtract. 0 minus 2 is negative 2. Right? So this is equivalent to 1 over 2 raised to 2. So what is any number raised to 0? Okay, so any number raised to 0 is 1. Okay, so we have 1 over 2 squared. So it's equivalent to 1 over 2 squared. Okay, so this is for negative exponent. So again, you can make the negative exponent into positive if you get the reciprocal of that expression. Okay, next is the fractional exponents. So let's say we have x raised to 1 over n. That is equivalent to the nth root of that number. So whatever the value of denominator will be the root, okay, of that number. So for example, we have 4 raised to 1 half. So the denominator is 2. So that will be the root of the radical. So this is equivalent to the square root of 4. But sometimes we don't need to write this root, which is 2, only square root. That is understood that the root is 2. And 4 can be expressed as 2 squared, right? So we can write 4 as 2 squared raised to 1 half. So that will be the left side of the equation. So this is equivalent to the square root of 4, which is 2. By the power rule, if you have a power raised to another power, you can simply multiply. So 2 times 1 half, of course, that is 2 over 2 or 1. So this is equivalent to 2. So we have now 2 is equals to 2. Okay, next is we can distribute an exponent over a product. So for example, we have this one, x times y, and we raise it to the power of n. So you can distribute that n over multiplication. Okay, so you can distribute to x and to y. Okay, so the power of product is equal to the product of the powers. So for example, we have this one, 2 times 3, then we raise to 2. So it is the same as distribute that exponent to both 2 and 3. So 2 squared times 3 squared. So 2 times 3 is 6 squared, which equals 2 times 2, which is 4, and 3 squared, which is 9. So 6 squared is 36, of course. 4 times 9 is also 36. But be careful with this one. We cannot distribute exponent over addition and subtraction. Okay, so take note of that. You can distribute exponent only over multiplication but not in addition or subtraction. So for example, we have this one, 2 plus 3 squared is not equal if we distribute that exponent 2. Let's say 2 squared plus 3 squared. So 2 plus 3 is 5 squared is not equal to 2 squared, which is 4, plus 3 squared, which is 9. So 5 squared is 25. 4 plus 9 is 13. So they are not equal. Okay, so the same applies with subtraction. But we can also distribute exponent over a quotient or over a division. So if you have, let's say, x divided by y raised to the power of n, so we can distribute this n along the numerator and denominator. Okay, so the power of the quotient is equal to the quotient of the power. So for example, we have this one, 1/2 squared. So this is the same as we distribute this 2. So we have 1 squared over 2 squared. 1/2 is 0.5, right? So 0.5 squared is equivalent to, of course, 1 squared is 1, 2 squared is 4. So 0.5 squared is 0.25, and 1/4, of course, is 0.25. Okay, so let's apply these rules to this simple exercise. So simplify the following expression. We have 3x raised to negative 2 divided by x raised to 4. So one thing to notice here is your x raised to negative 2, of course, we have a negative exponent. So how to make it positive? We simply get the reciprocal. So the reciprocal of x raised to negative 2 is 1 over x squared. So that will make your negative exponent positive. Okay, next we have now fraction. So this is the numerator and this is the denominator. So in algebra, we can proceed from division to multiplication provided that the denominator, in this case, our x raised to 4, we get the reciprocal. So the reciprocal of x raised to 4 is, of course, 1 over x4. So again, from division, we proceed to multiplication provided that the denominator, you get the reciprocal. Okay, so we have now 3 over x squared times 1 over x4. Of course, 3 times 1 times 1 is 3. And the denominator now is x squared times x4. So we have the same base. So when multiplying an expression with the same base, we add the exponent, right? If you remember the rule. So we have now 3 over x raised to 2 plus 4. Or that is x raised to 6. And this is the answer for this exercise. One thing to note from this exercise, take note of this. If, for example, you have an expression with negative exponent, so to make it positive, if it is located in the numerator, simply bring it down to the denominator. Okay, so we can skip these 2 steps. So actually, we can directly from this step to this expression. Again, if you have negative exponent, to make it positive, if it is in the numerator, bring it down to the denominator. That is located in the denominator, just bring it up to the numerator. So we have an example for that. For example, we have this one. Simplify the following expression. We have 4y cubed divided by y raised to negative 5. So we have negative exponent. Okay, negative 5. So actually, if you want to make it positive, just bring it up to the numerator. But I will show you the process why that is valid. So we have y raised to negative 5, right? So in order to make it positive, what we do is we get the reciprocal. So this is equivalent now to 1 over y raised to 5, right? And we have now again a fractional expression. So this is the numerator, this is the denominator. So from division, we can proceed to multiplication provided that the denominator, we have to get the reciprocal. So 1 over y raised to 5, the reciprocal is simply y over 5 over 1, or just simply y raised to 5. Okay, so we multiply now the same base. Okay, so we have y raised to 3 and y raised to 5 multiply. So by the rule of exponent, we simply add. So we have now 4y raised to 8. So this is the answer. So again, take note. So we can skip this process. So we have negative exponent. So to make it positive, bring it up to the numerator. So let's apply the same concept with this another exercise. So we have y and z at the numerator, another y and z at the denominator. So first thing we notice is your z raised to negative 2 is of course negative. So what we do to make it positive, we bring it up to the numerator since it is located in the denominator. So bring it up, it will become positive, right? So the problem now is we have y here, we also have y here. Okay, so we need to bring down that y. So if it is negative, if you bring it down to the denominator from numerator, it will become positive. Likewise, if it is positive, y3, you bring it down to the denominator, it will become negative. Okay, so positive y raised to 3, bring it down to the denominator. Okay, so it will become negative. So we have now the same base. Numerator we have z, denominator we have y. So we can simply add the exponents, right? So by the rule of exponent. So 5 plus 2 for the z and negative 3 plus 7 for the y. So this will be our answer. So z raised to 7 divided by 7 times y raised to 4. The next, another rule for the radical. So first is the radical over product. So this applies in the multiplication. So for example, we have multiplication process a times b. Under the radical sign, we can simply distribute the radical, or we can just separate that a and b. Okay, so the radical of the product is, of course, the product of the radical. So for example, we have this one, the square root of 4 times 9. So we can separate that 4 and 9. So we can distribute the radical that is equivalent to square root of 4 times square root of 9. 4 times 9 is 36. So square root of 36 equivalent to, of course, square root of 4 is 2, square root of 9 is 3. So 2 times 3 is 6, and the square root of 36 from the left side of the equation is also 6. But careful, we cannot distribute the radical sign over addition or subtraction. So only on multiplication. Okay, so take note of this. Okay, so careful with this one. The square root of 4 plus 9 is not equal to square root of 4 plus square root of 9. 4 plus 9 is of course 13. So the square root of 13 is not equal to, so the square root of 4, which is 2, and plus the square root of 9, which is 3. So square root of 13 is not equal to 5. So the same applies with subtraction. But we can distribute a radical over division. Okay, so we have the square root of a divided by b. So we can distribute, okay, to the numerator and denominator. So the radical of the quotient is the quotient of the radicals. For example, we have this one, cube root of 64 divided by 8. So that is also equivalent if we distribute the cube root in the numerator. So cube root of 64 and cube root of 8 for the denominator. So what is 64 over 8? Of course, it is 8. So okay, the cube root of 64 so is 4. So 4 times 4 times 4 is 64. Cube root of 8 is 2. So you multiply 2 3 times. 2 times 2 times 2 is 8. So of course, this one, cube root of 8 is 2. 4 divided by 2 is 2. Okay, next, the fractional exponents. Actually, we discussed this one, but what we have discussed is the fractional exponent have the numerator, which is 1. This time, the numerator is a number other than 1, let's say m. But the same concept applies. The denominator n will be the root, and the numerator will be the exponent. Okay, so take note. Okay, so the root is the denominator and the numerator is the power. Okay, so example, we have this one, 27 raised to 2/3. So 3 is the root, which means cube root of 27 raised to 2. Okay, numerator is the power. So the left side of the equation, 27 raised to 2/3, we can express this in terms of 27 raised to 1/3 squared. Right? So by power rule, we can multiply these 2 and 1/3. That will give us 2 over 3. So of course, in the right side of the equation, the cube root of 27 is 3. So you multiply 3 times will give you 27. So we have 3 squared. Okay, so how about this one? So 27 raised to 1/3, again, denominator will be the root. So this will become cube root of 27 squared. Wait, 3 squared is 9. So cube root of 27 is what? Of course, 3. So we have 3 squared equals 9, and that will give us 9 equals 9. So let's have an example. Compute this one. 25 raised to negative 3 over. Take note, negative. So how to make it positive? Okay, we get the reciprocal. So this is equivalent to 1 over 25 raised to 3 halves. So we're raising to the fraction. Take note, the root is the denominator. So this will become, of course, that is 2, which means square root of 25. So no need to write the 2. It is understood that the root is 2 for the square root. So we are raising to 3, since that is the numerator of the fractional exponent. Okay, so square root of 25 is 5. So you multiply it 3 times. 5 cubed, that is 125. So this is the answer, 1 over 125. Okay, another exercise. So simplify the expression, and one thing we can notice for this expression is your y is negative 5. So how to make it positive? Of course, bring it down to the denominator. Okay, so another one, we have x raised to negative 6. So how to make it positive? So from the denominator, you bring it up to the numerator. Okay, so we don't have now negative exponent. So we have x at the numerator, we have y at the denominator. So the same base, of course, we can add the exponent, right? 4 plus 6 for the x and 3 plus 5 for the y. So of course, it will give us x raised to 10 over y raised to 8. So 3 plus 5 is 8. So we have now exponent here. Okay, 3 over 2. Take note, we can distribute exponent over multiplication or division. So we can distribute this exponent 3 over 2 to 25, to x10, and to y8. Right? We can do that. That is the rule. So distribute 3 over 2 to each of this factor. So we have 25 raised to 3 over 2. Of course, the 10, so times 3 over 2. The same with 8. Okay, times 3 over 2. Okay, so what's next? So first is the x, 10 times 3 over 2. That will give us first 30 over 2. For the y, 8 times 3 is 24 over 2. Okay, so next is we simply 30 over 2 is 15. 24 over 2 is 12. So the next step is to work with this 25 raised to 3 halves. So the denominator is 2. That will be the root of the expression. So this is equivalent to square root of 25 raised to 3, right? Okay, so of course, square root of 25 is 5. So 5 cubed is 125. So times x raised to 15 divided by y raised to 12. So this is the answer. Okay, next example is rationalize the denominator. So when we say rationalize, we don't want any radical sign in the denominator. So the solution for this one is we simply multiply the square root of x by also another square root of x. That will cancel out the square root. I will explain later. So we multiply this to square root of x over square root of x. So what is the equivalent of this one? The same value, numerator and denominator. This is equivalent to what? To 1, right? Square root of x over square root of x. So it's just like multiplying this expression into 1. So nothing changes, right? So any number multiplied to 1 equals to that number. So we have now 3x times square root of x for the numerator. Square root of x times square root of x, of course, the same as square root of x squared. So take note of this. Whenever you see this pattern, square root of x squared, that will cancel out the square root. So y, okay, I will prove this to you. So this one is equivalent to square root of x. Take note, square root of x is 1/2, right? So 1/2 squared. So what is this rule? This is power rule. So you can multiply exponent and that exponent. So 1/2 times 2 is, of course, 1. Okay, so we have now 3x square root of x over x. And take note of this one. Whenever you can see u squared, the square root, it will cancel out that radical sign or that square root sign. Okay, so what's next? So we have common x. Of course, we can cancel that out. That will give us 3 square root of x as the answer. Okay, another example. So simplify this expression under the radical sign. The first thing we can notice here is that your z is negative 11. So how to make it positive? Break it down to the denominator. Okay, so we have now, of course, 6x squared y times 6 divided by z raised to 11. So from negative 11, we make it positive, bringing it down to the denominator. Okay, so what's next? Take note, we can distribute the radical sign over multiplication or division. So let's distribute this radical sign. So we can express this expression in terms of square root of 60 times square root of x squared times square root of y raised to 6. So divided by, of course, square root of z raised to 11. So we can distribute radical sign over multiplication and division, but not in addition and subtraction. So take note of that. So next is this one. We have x squared, square root of x squared. So what is square root? So what number when you multiply by itself, it will become x squared. Of course, that is x. So this is another thing to note. If you have square root of the squared, it will cancel out that radical sign, right? Since x times x is x squared. So which means the square root of x squared is x. Okay, so we can apply that the same concept to y raised to 6. So we can represent y raised to 6 as y squared times y squared times y squared. Take note, we have the same base. So we can add exponent 2 plus 2 plus 2, that is y6, right? Okay, so again, we can represent y6 into 3y squared. And take note, we can distribute the radical sign over multiplication. So let's distribute this radical sign. So we have now square root of y squared times square root of y squared times square root of y squared. So we can cancel out the radical sign. Take note, when we have squared under the square root, we can cancel out the square root. So to become now y times y times y, right? So it will cancel out this square root, and of course the squared under that square root. So we have now y times y, or that is equivalent to y cubed. Okay, so we can apply the same concept to z raised to 11, but first let's tackle this one, the square root of 60. 60 is equivalent to 4 times 15, right? So we can multiply 4 times 15, and since they are under the radical sign, we can distribute that radical sign. So square root of 4 is 2, square root of 15, of course not a whole number, so let's leave it as a radical under the radical sign. Next, we can work out with the z raised to 11. So we can express this in terms of what? Okay, c squared. So how many c squared? Okay, so we have 1, 2, 3, 4, 5. That is, if you add these two 5 times, that will give you what? 10, right? Then plus the last, which is exponent 1, so we have 11. And we can distribute the radical sign just like what we did in the x squared and y squared, so to cancel that out. But I will have another method for this one. So z raised to 11 is also equivalent to what? Z raised to 10 times z, right? So this is more efficient way. Take note, we can distribute the radical sign. So this is equivalent to square root of z raised to 10 times square root of z. So it's like separating that two factors, okay? So again, what is square root? That is raised to 1/2, right? So we can express this square root of z raised to 10 as z raised to 10 raised to 1/2. So another rule for exponent, so this is power, and power we can multiply. So 10 times 1/2, of course, that is z raised to 5. So times square root of z. And actually this is the answer, but sometimes if we are asked to rationalize the denominator, which means we don't want any radical sign in the denominator, so the same process to cancel out the square root, we multiply it by square root of z. But of course, the numerator also we can multiply by square root of z. So again, what is this one? This is a fancy way of multiplying by 1. Right? Square root of z over square root of z is 1. Okay, so square root of c times square root of c. Of course, that will cancel out the radical sign. So we have now z raised to 5 times z in the denominator. So this is equivalent to 5 plus 1, right? We can add exponent of the same base when we are multiplying. So this is equivalent to 2 square root of 15 x times where's y cubed times square root of c divided by z raised to 6. Okay, so we have two expression 15 and z under the radical sign, which means we can combine this one, right? So this is the final answer, 2 square root of 15z times x y cubed over z raised to 6. So why we can combine this one? Take note, we can distribute this radical sign over multiplication. So meaning we can separate, right? So they are equivalent. Okay, so this is the answer for this exercise. And this is the end for this tutorial. So take note of these rules, the exponent rules, and the radical rules in simplifying algebraic expressions. And I hope you learn a lot from this tutorial, and see you in the next one.